In this video, I'll talk about capacitance. Capacitance is defined as charge on either plate. When I say either plate, that means either the plate that is connected to the positive terminal or to the negative terminal of the battery. So the amount of charge on either plate divided by the potential difference between these two plates. That's how the capacitance is defined. Q over delta V is called the capacitance. The unit of capacitance is farad. And if you look the unit of charge, it is coulomb, and the unit of potential difference is the volt. So the farad is coulomb per unit volt. That is also called the farad. The 1 farad is a big capacitance. So in general, the capacitance are measured in smaller units, just like microfarad, nanofarad, or even picofarad. The 1 microfarad stands for 1 times 10 to the negative 6 farad. 1 nanofarad stands for 10 to the negative 9, and picofarad stands for 10 to the negative 12. If you look at this equation 1, what does this equation give you is that the capacitance depends upon the charge and the applied potential, but that is not true. The capacitance does not depend at all on the amount of charge stored and the applied potential. It depends on the area of the plate. This is the area of the plate, the distance between the plates, and if you feel some medium between the capacitor, just like it could be paper, Teflon, water, any medium, some sort of oxide. So it depends on the medium, it depends on the area, and it depends upon the distance between them. That's what determines the capacitance of a capacitor. Or in other words, we can simply tell the capacitance depends on the geometrical parameters of the capacitor, just like area, the distance, and the medium. But the amount of charge stored, if I look at this equation, what does this equation tell you? The Q is equals to C times the delta V. Okay, so that means the charge stored on a capacitor, depends upon the applied potential difference. That's what I have written here. The charge stored in a capacitor depends upon the applied voltage, but the capacitance does not depend on the applied voltage. Only the charge stored depends on it. Okay, if you look at this equation, Q is equal to C times delta V. C is constant, so if you increase the applied potential, the charge stored will also increase. So this is the introduction to the capacitance. Again, if you have any questions, please write down your question in the comment section below, and do not forget to subscribe the channel. Thank you.